Dear students, see, this is our new chapter, chemical bonding and molecular structure, molecular architecture. I am using a different word, molecular architecture. And this is one of the most important chapter of chemistry. And every time I used to say that bonding is the heart of chemistry, right? Bonding is the heart of chemistry. See, this is my understanding, what I have gone through since my study time and after this teaching. I have observed this, that this bonding is so important for your understanding of chemistry. So I think this is the for class 11th, this is the third core chapter of chemistry, and you can say this is a very strong pillar of your chemistry. So all of you should be very focused here in this chapter and try to understand each and every concept of this chapter, and definitely it will help you for your better understanding in rest of the chemistry, right? See, these are the points or major points which I will discuss in this chapter. Kosel-Lewis approach of chemical bonding. This is very elementary and very beginning of this bonding, what Kosel and Lewis has suggested regarding this molecular bonding or chemical bonding. Then formation of different types of bonds. Obviously, all of you have gone through class 9, 10 in your lower classes regarding this bonding concept. All of you must be knowing ionic bond, what are ionic bond, what are covalent bond. This is a just quick revision all these points. The ionic bond, in ionic bond we will focus this lattice energy, hydrogen energy and polarization. Although the calculation of lattice energy not feasible before thermodynamics, but I will try to explain you, and the calculation part I will left for in thermodynamics. I will detail discuss this lattice energy calculation and Born-Haber cycle in thermodynamics, because there is a cycle known as Born-Haber cycle used to calculate this lattice energy. So lattice energy, hydrogen energy and polarization, I will cover all these points here. So a little bit extra what you have already gone through in your lower classes, that will you will find here in this ionic bond. And this covalent bond, this is totally different. This is, I think all of you are knowing octet rule, what is octet rule and its limitation. Lewis structures might be knowing, this small molecules like H2O, ammonia, carbon dioxide, all these molecules might be knowing all of you. But the new theory is coming, valence bond theory and formal charges. Okay, little bit I will rearrange this. Formal charge first, then valence bond theory and hybridization, right, and molecular orbital theory. This is most advanced theory. So these two are the main theories, and these are the subtopics of this theory: formal charge, hybridization. This is the sub part of this valence theory, and molecular orbital theory. This is the most advanced, and the last one is the hydrogen bonding. So this is the aim of this chapter, right? Okay. See, first I will take little bit introduction of this bonding. See how this bonding is helpful for you. You know, in chemistry, major portion of chemistry includes basically the properties of elements, molecules, compounds, right? So first thing, properties of molecules properties of molecule molecules. It is the, and you know the properties, because the major portion of chemistry includes this properties. We always our main focus is to predict the properties, physical, chemical, whatsoever, but all the properties. So I am giving you one formula, and this is the start of my lecture. Properties of molecule is the function of, like all of you are writing in the mathematics, y is the function of x, like that I am writing here. So properties of molecules, it is the function of types of atom. Means types of atom present in the molecule. Means if someone is arguing, okay, H2O and H2S both have different properties, and one very evident property is that H2O is liquid at room temperature and H2S is gas at room temperature, right? So what first thing is coming in your mind, that why both have different state, H2O and H2S, although both were oxygen and sulfur, this is the difference, but hydrogen is common, so oxygen and sulfur both belong to the same group in the periodic table, and sulfur is much heavier than oxygen, although H2S is gas but H2O is liquid. So first thing should come in your mind that, okay, the difference in this property is mainly due to the difference in the atom. So what atom is different? Here H2 in H2O and H2S, obviously oxygen and sulfur. Hydrogen is common, so don't predict any property with respect to hydrogen. So oxygen and sulfur, the difference in atom. So types of atom. This is the major variable regarding the properties. Means if atoms are different, then the molecule have the different property. Second variable is, this is very important, connectivity. Connectivity of atom. What? Connectivity of atoms, right? This is bonding, right? This is bonding. Connectivity of atoms. Sometimes we will find that, okay, type of atoms are same, but molecules are different. Means matter have same, different properties. Then what is the reason? What is the reason? Why? If atoms are same, then why the properties are different? Right? So their connectivity also play a important role to affect the properties of molecule. And third is orientation. Orientation of what? Orientation of atoms or groups. Means group of atoms. Groups means here group of atoms, right? So these are the three variables. Sometimes you may find type of atoms are same, their connectivities are same, but properties are different. So this is due to the difference in the orientation of atoms or groups in space. So this is the equation, and we can say this is the master equation regarding the properties of molecules many times. Means from this single equation I can define you the isomerism, different kinds of isomerism, everything I can define with this only, this formula, right? So we will see time to time in your organic chemistry, in other parts of the chemistry. See, so first example, in the support of this formula, suppose that we have H2O, which is liquid at room temperature, and H2S is gas. So in properties, it might be possible that all the variables are present at a time, right? All the variables. But sometimes some variables may be consistent in both the or in all the molecules. So you should find out the point of difference. So on the basis of point of difference, you can identify, okay, this have different property and this have different property. So here H2O is liquid and H2S is gas. Although the molar mass of atomic mass of sulfur is more than the atomic mass of oxygen, much higher than the atomic mass of oxygen. So this can be explained. This can be explained on the basis of what? Can be explained on the basis of what? Bonding, right? And the first variable, what variable you are observing here, you can see here, this is sulfur, the atom, this is sulfur, and here this is oxygen. Hydrogen is common in both the cases, so don't think about the common element. So the properties, the difference in properties is mainly due to the, what? Difference in the atom. Connectivity, there is no issue of connectivity here, because this not much variation is there. 2 hydrogen and 1 oxygen, 2 hydrogen and 1 sulfur. So connectivity pattern is same in both the cases. Connectivity of atom you will see only when the type of atoms are same, then you will see connectivity, right? See, orientation of groups, this is different. This is different here, because if I will give you can be explained on the basis of bonding. So first difference, you can say that atoms are different. In one case oxygen, and in other case it is sulfur. So first difference, first point of difference is the different elements, and I am giving you the exact almost experimental data that in this water molecule O and H, the structure of this water molecule is something like this, and this bond angle is 104.5 degree, right? But in case of H2S, see this HS, this bond angle is close to 90 degree. See the difference, see the difference. So through bonding we will try to find out how this 90 degree bond angle is here, how this 104.5 degree is bond angle in case of water. We will try to answer all these questions in our upcoming topics, headings. See the orientation of atoms or groups in space, that is different here. Now see H as H bond angle is 90 degree here, 92 or 91 degree, and here H bond angle is 104.5 degree. So second difference what we are getting here, second difference is the, I mean, its structure. Structure. Its structure is different, architecturing is different here, the orientation of atoms in space is different, right? So this is what I mean, the point of difference which makes these two compounds have different properties, right? So the first variable is type of elements, connectivity of atoms, and orientation of atoms or groups, right? Clear to everybody? Good. So this is first example. Second example I am taking here. See, second example we can take. Suppose that we have C2H6O, right? C2H6O. So C2H6O, this is the molecular formula, and this we can right, and see, I am trying to make the structure a little bit relevant here. See, this is one of the structure, and another structure you can draw for this like this. See, this bond angle is close to 111 degree, and this is this bond angle COOH. This bond angle is close to 109 degree, 108 degree, right? So see the difference. Now tell me what is the difference. First variable is there. Answer is no. All have carbon, hydrogen, oxygen. All have carbon, hydrogen, oxygen. So what is the point of difference? The point of difference is the connectivity. Connectivity is different. Connectivity is different. And what other difference? Orientation. Orientation. So these two molecules which I have drawn for this molecular formula, so both have different properties. Both have different properties, right? What properties are different? See, suppose that if you see the boiling point of this and boiling point of this, right? So both have different boiling point. See, what is the boiling point of this? Boiling point of this is 78.3 degrees Celsius. And boiling point of is the dimethyl ether is minus 24 degrees Celsius. See the difference. You cannot imagine that, see, atoms are same in both the molecules. Carbon, hydrogen, oxygen. carbon, hydrogen, carbon, hydrogen, oxygen. See? So, and huge difference, 78.3 degrees Celsius. See, 78.3 degrees Celsius, and this is minus 24 degrees Celsius. Right? And here in this example, see, this is liquid and this is gas. So what a wonder we are observing here, that H2O liquid, H2S gas. Here see, carbon, hydrogen, oxygen, both molecules have same elements, but the huge difference in their properties. So this is the, strength of chemical bonding. Chemical bonding enables you to predict the properties of molecules. And you know, this theoretical prediction will help you, will enable you a future, if you are in the field of research, biological research or in any kind of research, this will help you a lot. Or any kind of research, if you are in the material science, then on the basis of molecular architecturing, bonding, you can theoretically, think of what kind of material we can modify, we can, prepare. So, what is the difference here? See the difference. There is a carbon-carbon bond here, but here no carbon-carbon bond, only carbon-oxygen bond is there. There is a oxygen hydrogen bond here in this molecule. Here there is no oxygen hydrogen bond. So this is the difference in the connectivity. Means in both the molecules, connectivity pattern of the atoms is different, as well as orientation. Orientation, it is different in all molecules almost. In simple molecules, suppose that you have taken H2 molecule, then what is the difference in the orientation of what H2 molecule may have the different orientation, right? So in both of these examples, one important point is there. See what is written here: hydrogen bonding. Hydrogen bonding makes the difference here in why H2O is liquid and H2O is gas. But to explain hydrogen bonding, this structure and difference in the type of atoms, this should be counted. So when I will discuss this hydrogen bonding, then I will explain you this. So see, I have taken three variables here which affects the properties of molecules and properties of matter. First is the types of atom, connectivity of atom, and orientation. So I have taken two examples in which in one example different atoms I have taken, in other example atoms are same but connectivity is different. Now I am taking third example in which atoms are same, connectivity is same, only orientation is different, right? And properties are different, right? So see why these two have different properties, due to the first observation that connectivity is different and orientation of atoms or group of atoms is different. Now see the third example. If we consider this molecule, see what is the difference? If you observe here, C double bond C, C double bond C, C single bond C, C single bond C, C single bond C, CS3. The only difference is C, orientation of C. I have taken these two groups. So in one structure they are in the same site, and in other structure they are in the opposite site. See, rest part is same, connectivity is same, everything is same. The only difference is the orientation. orientation of groups in space, right, in space. So see, due to this difference in orientation, both have different properties. Like suppose that if we talk about melting point, so I am not let the melting point of this is x and melting point of this is y. So I have not remembered right now. So I have taken x and y. So melting point of this is x and this is y. So melting point of this compound means y is more than x. Y is more than x, right? Means the melting point of this compound is more than this compound. Similarly, boiling point of this is more than this. Similarly, heat of hydrogenation of this is more than this. This is more stable, this is less stable, right? So stability, if you consider, so melting point of this is more than this. So melting point of 2 is more than melting point of 1. Boiling point of first is more than boiling point of second. And stability of second is more than first, right? So all these are the difference in their properties, and this is attributed to the orientation of groups in space, nothing else. Rest part is same, everything is same. The only difference is the different orientation of atoms or group of atoms in space, right? Okay, so now it is clear to everybody. Good. See, so this is a little introduction how properties of molecule depends on the different factors. Now next point. See, one question arises in our mind that why elements combine, right? So the question is why elements combine. Right? See, combination of elements, it is a kind of process. So whenever in science, particularly in chemistry, whenever we are talking about any process, so you have to every time think about energy, because energy is a major driving force, or we can consider energy as a major driving force for any process. So if anything is happening around us, any process is going on in a particular direction, so you think about energy. I'm not talking about other subject, but at least in chemistry, energy is the main driving force. One more factor is there in thermodynamics, I will talk about that is entropy, but energy is a main driving force for any process. So whenever we should talk about any process, so combination of elements is a kind of process. So this is think about energy. So the answer is basically Why elements combine? So the answer is to decrease the energy or to become stable by decreasing energy, right? To become stable by decreasing the energy energy of what? Energy of what? I have written to become stable by decreasing energy. Means, is there any relation between stability and energy? The answer is yes. So I am writing here, stability is inversely proportional to energy. Again the question arises, any kind of energy, or which kind of energy we should take here to explain the stability? See, in chemistry, you will encounter with very different type of energy. Sometimes you may find lattice energy. Sometimes you may find resonance energy. Sometimes you may find total energy or average energy, right? So this stability is basically inversely proportional to average energy, right? Not always, because sometimes you may get, okay, energy is stability is directly proportional to energy. So here what I am talking about, average energy of what? My question is still unanswered. That energy of what? Average energy of what? To become stable by decreasing the energy of what? Energy of molecule. So how to compare? Let's example we can take. Suppose that this is the energy coordinate, right? Energy is increasing here. So if you take two hydrogen atoms, when they are isolated, these are atoms, this is the atomic state, and when they form molecule, this is the molecular state, right? So here the energy of this molecule is less than the sum of energy of their corresponding atoms. From this statement, you won't have any clear picture in your mind, right? From here you can get clear that when elements combine or atoms combine with each other, the energy of the result of that combination, whatsoever molecule, whether it is ionic or covalent molecule, whatsoever the molecule is producing, the energy of that molecule is less than the energy of the contributing atoms, sum of the energy of the contributing atoms. So you can say the energy you can directly add or subtract, no problem. So the energy sigma of average energy, you can say average energy of atoms is more than the average energy of molecule. energy of molecule, right? So you can write or you can explain that right? The average energy of sum of average sigma of average energy of atoms is more than the average energy of molecule. Okay, so this is the cause of the combination of elements or atoms. Now this we can explain with the help of some energy. Now see, we can take some energy plot, variation of energy in the formation of molecule. Let's see. See, this is the energy plot when molecule formation is taking place. So I am taking a very simple molecule atom. Suppose that this is one atom. We are taking the position of one atom here and another atom here. See, these are two atoms. Suppose that this is B, atom B, and this is atom A, right? See, and now see here, separated atoms. Now A and B are separated from each other. So the energy between them, this is the energy coordinate. So energy is 0. So when A and B are separated, the energy means energy of A is not 0. Energy of B is not 0. Energy with respect to each other means the interaction energy, or you can say potential energy. You cannot say that energy of A is 0. The matter, when the matter exists, it has energy. So what energy, which kind of energy I am talking about here? The interaction energy, the potential energy, you can say in a simple word, in your words. So when they are separated far enough from each other, the potential energy or interaction energy interaction or potential energy is equal to 0 with respect to each other. Means we are not telling, I am not telling here that the energy of A is 0 or energy of B is 0. Energy of interaction between A and B is 0 with respect to each other. Means both are not interacting with each other. Both are not interacting with each other. There is no interaction between them. So what we can say, what we can put a note here, that no interaction between A and B, right? So this concept is forever for you people, because when there is no interaction between two objects, the potential energy with respect to each other is 0. right? And I think in atomic structure I have already explained you this point. Okay, now see what this line represents. This line represents the total energy, variation in energy with the distance. Now this B is moving towards A. We are assuming that A is fixed at its point. So B is moving, and this is the lowest point of energy. This is the lowest point of energy. Yes, better. So when this B reached here, nucleus of B reached here, now the potential energy between A and B, this is A and this is B, the potential energy is minimum. You know, the distance between this A and B here, this distance, this is called R0 distance, and at this R0 distance, these two forms the most stable system, means most stable molecule. Now if you try to push this B to more closer to A, its energy now increasing. Now this is increasing energy, and the system becomes unstable. Means what we can conclude from here, that when the two atoms are coming close and forming a molecule, then there is some optimum distance at which the potential energy of the system is minimum. And if you push the atoms more closer than that equilibrium distance, then they again start to repel to each other, right? So this line is representing the E total means E attraction plus E repulsion. See, this distance is infinite distance. So from R infinite to R naught, this attractive E attraction is dominating over E repulsion. And now when this distance between them is smaller than this R naught, now this repulsion becomes dominant over attraction. And slowly, and this attraction is what? Negative, C, negative, and more and more negative, right? And once you push much closer than this, then the energy becomes what? Positive. So this line represents the E total attraction plus repulsion. Clear to everybody? Okay. Suppose that if you take any line like this, any plot like this. So at this plot, it is the non-bonding plot, you can say. Means along this path there is no molecule formation. So this is non-bonding plot, because you know for bonding E total must be less than 0. E total for bonding between two atoms, for bonding interaction E total should be less than 0, right? So this graph from here to here, it is bonding interaction, and once this will place here, the energy becomes what? Positive. And for non-bonding interaction, E total is greater than 0, right? So this is the variation of energy. This is the variation of energy for what? The formation of any molecule. So this graph is very useful graph, you can say, in your life as well. See, when you becomes friend of someone, the energy between both of you is decreased. So all of you are wondering what this energy, which kind of energy? You know, humans also carry some energy. But I am naming that energy, not potential energy, not kinetic energy. I am naming that energy that is called ego. So ego is a kind of energy which every human carry. This is my own, interpretation. And this is very much fulfill here. Very much fit here. So when you are making some friendships to some other people, energy of both of you decreases in the same manner, but up to an optimum distance. So you know, in every relation, this R naught distance is very important. If you try to encroach to this R naught distance, your bonding becomes weaker. Energy will increase and bonding becomes weak. And if you are away from this R naught distance, then also energy will be less. So, and this is different for different individuals, because here I have taken AB, then this distance is something different. When you take AC, then the distance is different. When you take AD, so this R naught distance depends on the person to person. So what I am explaining, this is a kind of bonding, means the bonding between A and B is similar to your friendship with some other people. So in friendship, your energy, means ego is released. And if there is no decrease in ego, there is no friendship. So there is a decrease in ego when two individuals come close to each other, and at R naught distance, the ego is minimum, right? You can understood this like this, that is it possible that some stranger will call you by some abusing language? No, not at all. But your friend can abuse with you, because there is no ego between you and your friend, right? So ego is a kind of energy which decreases when two individuals are making a bond of friendship. So friendship is a bond. Now tell me, there is a bond between you and your friends, Is it visible to you that there is something linking between both of you? No. The same here in the chemistry as well. Don't try to find out where is the bond. See, there is no such, permanent bonding is there. Permanent structure is there. It is a force of attraction basically. This is the force of attraction. So the attractive force between two individuals, between two atoms, is called a chemical bond. It's called a chemical bond. So this graph is very much relevant for molecule formation and for your friendship formation or any kind of relation between two individuals. So every time you have to, very much clear that there is a optimum distance between two atoms at which the energy of the system is minimum. So try to maintain that equilibrium distance and listen carefully. For every individual, this distance is different. Because someone may like that you are encroaching his or her, personal, closer distance, but someone may not like. So you have to feel it, you have to assess it, then only you can have a good relationship, a good bonding with your partner, right? So this is a very useful graph and which will, help you a lot in your, scientific world as well as in your, friendship, word of friendship, right? So, okay, so this R naught distance between A and B, this is called what? Bond length. So from here you can define bond length as well. So bond length is the distance between two atoms, distance between two atoms at which the potential energy, the energy of the system, energy or potential energy of system means molecule, is minimum. So in the above case, what is the bond length? The bond length is R naught. Bond length is R naught in this case. See here. Now we can see from here to here. See, from here to here, what is this? This is called bond energy. This is called bond energy. Means this amount of energy from here to here, this amount of energy is released in the bond formation. If you provide this amount of energy to this system, again this B will be at infinite distance, right? So the bond, this amount of energy is released during the formation of bond. So if you provide this energy to this system, means this molecule, the bond will cleave. So this bond formation is an exothermic process, you can write. So bond formation, in the bond formation, energy released from the system. Energy released from the system, right? And the amount of energy released, that is called bond energy. And the amount of energy released is called bond energy. Bond energy or bond association energy, or bond association energy, right? And you know, if you provide the same amount of energy to the system, then this bond becomes dissociate. So for any given bond, bond association energy and bond dissociation energy both are equal. So you can say bond association energy is equal to the bond dissociation energy. Dissociation energy, right? Magnitude, right? Magnitude is always equal for given bond. For given bond, right? Bond dissociation energy is always positive. So sometime in your chemistry chapters, you will find bond energy. So if there is a bond term bond energy, so you always understood, okay, bond energy is always bond dissociation energy. This is the default. So bond energy is always equal to bond dissociation energy, that is positive value, right? It is never reported negative. Why we are taking bond energy is not equal to bond association energy? Actually, in nature we are getting molecules already bond formed. We are not going to make the bond between hydrogen and hydrogen or between oxygen and hydrogen. In the nature, these bonds are already formed. So we have to study in the laboratory to make them dissociate. So our always experimental value is the dissociation energy. So we are on the basis of the law of conservation of energy, we are always considering that, okay, whatsoever the amount of energy required to dissociate bond, definitely that amount of energy is released during the formation of that bond, right? So this is the approach. What is the why to write bond energy is bond dissociation energy, not bond association energy, right? So see, much information we are getting here from this graph, and this is very useful graph for material science, and this is true for every matter as well. Means whether they are atom or even if you bring two molecules close to each other, same graph is applicable. If you bring two objects close to each other, same graph is applicable. So this is very important plot, right? Okay. So this is bond length, bond energy, bond dissociation energy, bond formation energy, everything is clear. Okay.